Very dark and gloomy conditions here in North Texas. The temperature has been steady in the 40s, and as you saw, weak, low-level flow is picking up from the south, coming out of the frame towards the camera. So we're starting to get a little bit of that southerly flow again. But for now, at the surface, we have a cold dome here in Texas. A lot of action taking place in California. See a very large area of showers and rain coming onshore, and also working down the San Joaquin Valley. This is due to a front that's moving through California right now. Let's check out the surface plot, and this is what it looks like. It's probably a little hard to kind of get adjusted to looking at weather conditions in the western U.S. because the patterns are so, they're not as clear-cut as what we have in the central U.S., where you have a big low, you have a very well-defined front, and winds out of the south here, winds out of the north here. Friction kind of disrupts things quite a bit out there, and probably the best way to take a look at this is to look at the extremes of the map. Look what's going on at the top of the map and the bottom of the map, and then gradually work your way into the center. So what do we have in Arizona? We have southerly flow and temperatures in the 60s and 70s, and here's an 85 here. So very warm conditions across Tucson and Phoenix, all the way down to this 90. That is some pretty warm weather, and you can see a lot of southerly flow across Arizona. Then as we work up towards Las Vegas, still southwesterly flow, and when we have that in Las Vegas, that's going to be associated with the warm sector. So far, here's the warm sector, and maybe even all the way up to Salt Lake City. At the top of the map, though, we have kind of a different story. We've had snow in Portland and some very cold weather up there, and now we have fog and stratus settling in over the high deserts. North wind, a lot of these places here, so this is going to be the cold sector. So with that in mind, we're able to kind of narrow down exactly where the front is. So it looks like it's going to be somewhere in the San Francisco, Sacramento, Reno area. I might go for something like that. So basically it transitions from a fairly moderate south wind in this region to an area of calm wind or northerly flow up here. And there's probably a little more happening aloft when you get up to 850 or 700 millibars, because there you're going to pick up some of the faster flow. Now, another way to analyze what's going on, of course, thickness chart, but also looking at the soundings. Again, start at the extremes of the map, like Salem, Oregon. So here you can see there's a frontal inversion, maybe two of them, all the way up to about 8,000 feet. Then above that, this is some of the warmer air. If we go to the south part of the map near Tucson, much different picture. We have very warm conditions near the bottom of the sounding. And we start out here at about 77 Fahrenheit and very dry near the surface. A little bit of a elevated moist layer up here at about 18,000 feet. So probably a little bit of low cirrus stratus up there, cirrus. And then you go all the way down to Mexico. Yeah, pretty much the same picture here, very warm conditions. So you can also use the soundings to kind of like narrow down what's happening. Here, all we have in Salt Lake City, just a radiational inversion near the surface, since this is actually 0Z, so that's probably some trapped cool air close to the surface, but above that, fairly warm conditions. So you just kind of work your way in, and here's Boise. They've got a little bit of a north wind here, and the column itself is a little bit cooler. So at the surface, we bottom out at about 35 to 40 degrees Fahrenheit. So as this cools down, we're starting to get further north into the cool air. So let's check out what's happening on the satellite picture. There's, you can see the weather system moving inland, and of course that's going to make it into the central U.S. in a couple of days. You can see the characteristic lee side cirrus in Colorado right here, blowing downstream into Kansas and Nebraska. And out here off the coast, we're probably looking at a jet running something like that. We'll try red there. That looks a little bit better. And probably the major shortwave trough is going to be starting to come on shore here around Los Angeles right now. Then I was looking to see if I could find the upper level low. I can see a little bit of upper rotation here, going by the colder cloud tops in here, this region. And then down at the surface, you can see the cold air advection stratocumulus working southward down the Pacific. And that's these warmer, darker cloud fields you see right there. So a lot going on out west, and let's kind of put it together using the thickness and surface pressure. Very similar pattern to what we've seen over the past couple of days with a front out in the Atlantic down to the Gulf Coast. And then it looks like that probably arcs northward as a warm front somewhere through the Colorado and New Mexico valleys. And then it carries into Nevada, and then we pick up the front itself through California. So yeah, that's going to be in the Sacramento to Stockton, San Francisco, Oakland area. And that, of course, will be working southeast and eastward pretty quickly. Bulk of the cold air is over northern Saskatchewan and Manitoba. And we've got a very pronounced northerly gradient through here, so that'll carry the bulk of that cold air into the Great Lakes region. But you can see there's a little bit of this thickness troughing out here. This is a big blob of cold air coming in the backside of this weather system, and that's going to be the other punch that's going to make it into the central U.S. So we'll look for that on the GFS chart. Okay, let me get our charts all set up here. We'll run this back and get this ready to go for our forecast. Oh yeah, I guess we might as well just check very quickly what's happening at the surface elsewhere. There's the picture in Texas. You can see very cool southeasterly flow here. Looks like Oklahoma City reporting a little bit of freezing drizzle. So the edge of the front is running basically through Monterey up to the Big Bend area. And you can see just out to the west there in El Paso, very warm conditions, 65 at El Paso and even near 80 at Chihuahua. And this is kind of significant because as we erode this front and the next system comes at us on Saturday, we're going to get probably a little bit of downslope working from these higher plateau areas into Texas. And that's significant because Chihuahua here is up at about 3,000 or 4,000 feet. When you drop that dry adiabatically at about 5.5 degrees Fahrenheit per 1,000 feet, that could warm up pretty significantly. You know, of course, we're not going to see 100 degrees in Texas, but we will preserve a lot of the warmer temperatures as that moves eastward. And it shouldn't modify that much as it works into Texas itself. Florida in the southeast, not really much different. Very cool conditions, 33 there at Atlanta. Very cold weather in the northeast. Got 17 degrees there at Albany. And 10 there at Syracuse. Is that Syracuse or Utica? Somewhere around there. But -6 upstate, and then -2 in Montreal. This is some very cold air working in from Ontario, and we do know that cold core a few days ago was in this area, so that's shifted southeast. Then in the northern plains, also very cold. A lot of single-digit readings up there. And then as we go into Canada and see what's going to be probably heading into the U.S. over the next couple of days, sub-zero. A lot of -10 to -5 degree temperatures there. So, pretty much to the northwest and to the west-northwest, we are just kind of surrounded by cold air. And if we have some of that dry, if some of that air is dry, we could also get some dynamic cooling from evaporation. That could be a factor later on as that precip starts developing in the central U.S. All right. Hello to everybody. Let's see. We got Mark and Jason, Michael, Sue, see Mark, Ron, Kevin, and hello to everybody. Mount Washington, minus 27 with a wind chill of minus 76. Yeah, that's that cold air mass moving through this area, and probably some very steep lapse rates. So at the mountaintops, probably pretty cool there. All right, so let's head into our forecast. For tomorrow, for Friday. That's right, we're coming up on Friday. Things start to kind of come together in the North Plains and the west. So that frontal system will be moving into Arizona and Utah. And of course, we're bringing these 70s and 80s here in Arizona together with these cold zeros, 10s and 20s. So we're going to get a lot of baroclinic development of that front in the Rockies. Then for Saturday, it looks like some of that Arctic air moves southward into the Central Plains. The bulk of the Pacific air probably still hanging out over the Rockies, but looks like we're going to carry a slug of that polar air southward into the South Plains. So that's going to come into Texas Saturday evening. And a little band of snow showers back behind it. So that'll sweep through pretty quickly, and Sunday will be pretty blustery in Texas, that 540 thickness line coming into Dallas, and all the way down to Kentucky, Pittsburgh, and the front all the way down into Mexico, pretty far southward. And then we'll be pushing southward through Arizona, probably somewhere in this area here, around the Gulf of California, so that'll make it south even that far southwest. Then for Monday, the remainder of the high moves into the southeast and southern U.S., so a lot of cold air in place over this region, and the gradient is kind of set up more towards the southeast, so the east coast will probably get the majority of that cold air. Looks like a plateau high setting up over Salt Lake City. And for Tuesday, next system coming into Washington here, things get a little bit, they moderate a little bit in the central U.S. Not much going on for the 22nd either. Thursday also looking pretty quiet across the U.S. Developing a little bit of lee side troughing here. And it looks like there's a little bit of a chunk of polar air coming into the western U.S. on the 23rd. That's on Friday. And if we look at the pressure patterns, yeah, it looks like we've picked up a little bit of a front in New Mexico and Arizona. So that's going to bear watching right there. Let's see where that was 24 hours before. That kind of snuck right in there, didn't it? Looks like that's right around here. Very weak front. Actually, maybe a little further south, maybe like that. Try that again. Maybe something like that. So very weak front, rapidly picks up intensity, and then we really see it on the charts there on Friday. So probably some weather in the central U.S. on Christmas Eve. Yeah, there we go. 992 millibar system over Iowa. Cold front extending down to Texas. And probably a weak line of thunderstorms and showers. I did look at the Cape values, and the highest Capes were near the Gulf Coast, so I don't think we're going to have too much problem for severe weather. Then for Christmas, system moving into the Mississippi River Valley. And that is the Canadian model, actually, so let's check out the GFS and just pick it up from there. We'll start on Christmas. going for a very similar pattern. It looks like it's going further south with that low, so the system is going more for Dallas and San Antonio, whereas the Canadian model, you can see it went a lot further north into Kansas and Iowa in Wisconsin. So a really big difference there with the north-south positioning, but the east-west positioning pretty well correlated with one another between the Canadian and GFS model. So either way, it looks like we'll be busy on Christmas Eve. And we will be doing the forecast then, so don't worry about that. 26th, the system moves eastward, so it should be in the picture there. Then it looks like a period of quiet weather, a little bit of a Alberta Clipper coming through on Wednesday. 29th, quiet again. Another Alberta Clipper working through the North Plains. Then New Year's Eve, not quite there, but looks pretty quiet across much of the U.S. Okay, believe it or not, guess what's up next? All right, we're going to cover a little bit of pressure because we're looking at that just every day. So this is an interesting graphic I found on Hurricane Management Group's website. This kind of pins down all of the pressure readings that we use. Now, this chart here shows station pressure. Now, we don't get these on the observations or on the maps, but these are used to compute sea level pressure and altimeter setting. So you can see if you're at sea level, everything is going to match. Sea level pressure, altimeter setting, and station pressure. But if you take that barometer up to a station up here on a mountaintop, it's going to read 840 millibars. Or if you have a readout of inches, it's going to read 24.81 inches. So you can't use that on a weather map because if you try to analyze station pressure like this, you're just going to get a contour map. That's not helpful for forecasting. You have to reduce that to sea level pressure so you can compare that with other stations that are also reducing the pressure to sea level. Now, the easiest way to do that, you take the elevation. Let's see if I have a calculator online. There should be an altimeter setting calculator. There's one at the El Paso Weather Service El Paso site, so we'll give that a try. That chart had 1,800 meters. I'm just showing you how straightforward this is. 840 millibars. And we convert that and we get an altimeter setting of 30.8 inches, or 1042 millibars. So that's pretty easy. And that's because we're making an assumption that the column all the way down to the sea level pressure is at standard atmospheric temperature and density. So basically, when you have a home barometer and you're looking at a reading of that, you're basically getting altimeter setting because it's pretty straightforward. But as you go higher and higher, if you go to a higher elevation, it becomes a little bit more tricky to get to convert that reading down to the surface because the instrument is going to be sampling less and less of a pressure change as you go up because there's less molecules acting on that. But in any case, basically it's pretty straightforward to get altimeter setting. The other one is sea level pressure, and that's where you take the actual observed conditions, you take the 24-hour temperature trend and climatological reduction factors, and then you can compute that where that is at the surface. And basically that removes the tides of pressure variations from day to day, the diurnal pressure variations. That also removes local effects and other things that will make it. Basically, it makes it easier to compare one station to another. And I'll just give you a quick look at a surface chart here. it's very important to know which one you're looking at when you're doing surface analysis. And you basically just look at the plot here and you see what temperature or what value range it's in. This is going to be in the range for sea level pressure. So we're looking at here, Lufkin 1024.9 millibars, 1018.4 millibars. So that's sea level pressure. Now there are some charts that will give you altimeter setting, and that'll give you a few more values like here, where they're not reporting sea level pressure. But the problem is that'll introduce a little bit of noise into the chart. But the added information can be helpful for mesoscale analysis on a storm day. So that's your building blocks for sea level pressure, altimeter setting, and station pressure. You can look all that up online, and I'm sure there's some tutorials about that go into more detail. Okay, I guess I'm done here. Sue asked if I was going to look at the Canadian model December 25th. I think we probably covered that just after you posted that. Yeah, just kind of a north-south difference there. We're going to probably be able to resolve that a little bit better tomorrow. All right, I think I'm probably done for tonight. I appreciate you watching, and hopefully we'll see you tomorrow. Thanks.